So here is the actual Excel spreadsheet. And so, like I told you before, what we want is we want our input variables to be all in one spot. So when we make a change that affects the model, we only have to make the change in one place. And I've highlighted the two variables that we're going to change. The ANC visit, right now the status quo is at 88%, and we have the overall prevalence at 10%. And so all we're doing in our sensitivity analyses is that we are changing these variables and then see what our outcomes are going to be. And down here, I have our outcomes already calculated. And what we're going to look at is how the depth and the cost effectiveness, the incremental cost effectiveness ratio change as we modify these variables. And so with our status quo, you saw these numbers before as far as the number of deaths from our decision tree. And here we have the cost effectiveness ratio from our status quo. And so if we just, for example, change the people who will come into the ANC visit to 17%, and maybe we change the prevalence to the highest level, which is at 0.63%, you'll see down below how much the number of deaths varies. And you see that the number of deaths varies. It increases a lot. It almost doubles from what our status quo was. And when we go down to our cost effectiveness ratio, we see that we also get a big drop in how cost effective our interventions are. Before it was, I think, over $200. Now they're right around $100. So you can see there's a big variation in your outputs based upon the inputs that you provide. And remember, we want to set up our spreadsheet like this so we can go back and make multiple changes without having to put all these numbers or these calculations in the tree. And so real quick, we can change the ANC visits to 50%, and we can change the overall prevalence down to, I think, let's just say 5%. And you can see the impact that we have, again, on our outputs of interest. And you see that the number of deaths goes about equal to what we had before, but we see that the cost, the incremental cost effectiveness ratio increases a lot. And so this can tell you quite a bit about the robustness of your model, how important these variables are. So we really highly encourage you to do the sensitivity analysis so you can get a better idea of what could possibly happen in your model and how it would affect the decision maker's decision. So let's go back to the presentation. And so here we have the results of the model. And these are the different combinations that we use in our Excel model. And you can see that the worst case scenarios as far as deaths occurs when we have no intervention, which is what you expect. But what we notice within our best case scenarios, the top two, we get one from screen and treat and one from treat all. And it occurs when we have a very low prevalence and we have a high number of people attending the ANC clinic, which is what we expect. But now we have numbers to go with it. You know, how big of the number of people that deaths are prevented when we have such inputs as we have off to our left. And then down below, you see our cost effectiveness ratio, our incremental cost effectiveness ratio. And you can see that when we don't have a very high prevalence and we don't have a lot of people coming into the clinic, incremental cost effectiveness ratio is over $1,000 or close to $1,000. So it's very expensive when you don't have a very high prevalence and you don't have a lot of people coming into the clinic. Again, this is what you expect, but now you actually have numbers to help you make a decision about this. And when you have a very high prevalence and very high number of people coming to the ANC clinic, it's very cheap. And so you get a wide range of outcomes based upon how you do your sensitivity analyses. So let's talk about some of the conclusions from the sensitivity analysis. You know, as we expect, the higher the prevalence and or attendance, the better the options perform. And that's for both options. You start to see that treat all have less deaths as prevalence increase. And so treat all starts to look more and more, better and better. Screen and treat goes up as the prevalence in ANC visits also increase, mainly the cost. Screen and treat cost actually goes up as the prevalence of ANC visits goes up. And that's what you expect. The more people you have coming into the clinic, the more cost you're going to spend. With the treat all, it really just depends upon the number of people coming into the ANC clinic. The more people that come, the more money you're going to spend per patient. But in reality, the only time that you're going to use the treat all is in very specific situations, like in a target group. Maybe some of the female sex workers or a group that may just have a high prevalence for who knows what reasons. But it's nice to know the potential impact that could happen if it was feasible to treat all. That's the end of my presentation for today. Please consult your mentor about any sensitivity analysis that you want to perform. And again, I highly emphasize that doing a sensitivity analysis is very important because the results that you could get based upon a sensitivity analysis could actually change the decision of the decision makers.